Hello, our next speaker is Florian Opser, who will be talking about Unwind, a privilege-separated validating DNS recursive name server for every laptop. You have the floor. Oh, thank you.
Can you switch this over?
Oh, yeah, I will. Other people's laptops are the worst.
Okay. Good afternoon. I'm going to talk about Unwind. I'm Florian. I'm an OpenBSD developer since 2012, where I mostly specialize on privilege-separated network daemons. I've also poked at things in the network stack, and since of this week, my total contributions on OpenBSD have been a net negative. I deleted more lines than I added. And I'm not going to talk about this because that will give Andre nightmares, I think. For work, I work as a senior systems engineer at the RIPE NCC, where I'm a part of the team that runs the K-root nameserver, which basically means we have to figure out how to answer NX domain real fast. But more about the things that I do for fun. So OpenBSD has been described as a hiking club with a computer problem. So when we get out of our basement, we go on hackathons, we meet up in all these beautiful places. And so we need to travel there. And you might end up on a train or hotel Wi-Fi. You might be in an airport. And you're always stuck with what the network provides you DNS-wise. Sometimes you find yourself behind a captive portal. You need to get past that. And so we were thinking, can we automate this? You always fiddle with your configuration. Can we have a daemon running that handles this for you? That handles the harsh locations, DNS-wise, network-wise. Well, actually, no matter how harsh they are, maybe you find yourself in a hut in the Rocky Mountains in the snow behind a satellite link. And we have done this twice. It was awesome. So what did people do before on their laptop? You just run DHClient. It takes over resolve-conf. You will get past captive portals with this, because that's how they're designed, how to get past them. But you're at the mercy of the nameserver operator, that whatever the network hands you. You don't have DNSSEC in the sense of you don't run the crypto on your laptop. So maybe the nameserver does this, but it gives you an AD flag. Can you trust that? I don't. It also probably doesn't give you privacy. Really depends on what the thing behind this does, but not on the first hop. And your resolving runs in the same address space. So if I run ping FOSDEM.org, this goes to libc, uses stop resolver there, and talks to something that I don't know who actually runs this. Can I trust this? It hands me back a network package which I then need to parse. A variation on this is, yeah, I really don't trust that network. I put one of the quad access in there and resolve-conf. This will very likely not get you past captive portals. And it also will not work in places where DNS is filtered. Then in OpenBSD, we do have unbound in base, so people figured, well, we can just run that, which gives you then a DNSSEC validation. You can have privacy with DOT if you configure a line. It will very likely not get you past captive portals. And it will not work in places where DNS is filtered. However, it runs in a different address space. There are some other options that you can do. There was a talk last year at FOSDEM about systemd resolved, which seems like they're trying to solve the same problem that we are trying to do with Unwind. So that was certainly an interesting talk for ideas. Now, what does Unwind promise? Again, we're taking over resolve-conf. We get DNSSEC validation, we get DOT if you configure it. It will get you past captive portals. It will work in places where DNS is filtered, and it runs in a different address space. The architecture, so we want to run this always, so we need to get this secure. We're following the standard OpenBSD privilege-separated daemon architecture, which mostly consists of 3 processes. We have this design in multiple daemons already, and using that template, it gives us IPC over pipes with structured data. We don't need to reparse it. It gives us a config file where the grammar is very similar across the daemons, so people are already familiar with the config language. Oh, yeah. And It also gives you a logging framework where it logs the syslog, or if you run it in the foreground, it will automatically log the standard error, and the CLI tool. Now, the three processes, we have a parent process that just spins everything up. It's privileged, it opens port 53 and hands that over to the front-end process. It asks DH client for, oh, did you learn some name servers? Please tell them to me. And we run the processes in a reduced service operating mode. With the syscall, we have an OpenBSD, it's called pledge, and it's literally just this string, which means we pledge to only use the standard IO parts of libc, talk to open file descriptors. That's the standard IO pledge. We pledge to only open files for reading, and for technicality, we can then send file descriptors over a socket, over a pipe, sorry. And if you do something else in that process, it just gets killed by the kernel. The second process is the front-end process that gets the queries from a client, which then parses it and hands over structured data to the resolver process. And when it gets a response back from there, it sends that back to the client. This part also handles the control socket, and it gets informed by the kernel when an interface goes up, down, or interface just disappears, and also the learned name servers arrive here. So this is the process that's mostly exposed to the outside, in the sense of where user interaction comes in. And the final process is where we do all our heavy lifting for DNS. And this part needs to keep track of various resolving strategies. I'm going to talk later about what those are. It receives a query from the front-end process, finds the best strategy to get this resolved, and when an answer comes back, it passes this back to the front end. And since this one does do all the DNS resolving, eventually it needs to talk to the internet, so it has the INET pledge in there, which basically means you're allowed to open a socket and talk to the internet, but not a lot of more. Oh, there's one thing, since we do support a DOT, we need a search bundle. But we don't want this process to read the whole file system, so we can tell it with the unmail syscall, look, there's only this one file. Only this file exists in your whole file system. If you try to open something else, the kernel will tell you this does not exist. So you cannot exfiltrate any information that's on the file system. It's just not there. Time for a breath. Let's talk about the resolving bit, because this is, I suppose, the interesting part for this room. And so I mentioned that I run a name server for a living, which means I go to all the conferences and go to the DNS talks. And what the implementers tell me is, oh boy, it's really terrible to implement a resolver. Don't do that. And no, I'm not doing that. We're just standing on the shoulder of giants and use libunbound for that, which is the working horse for Unbound. And for technical reasons, we have a local copy in there, because the API does not expose all the things that we need, so we need to poke at some internals. But this is certainly not a fork. I do not want to maintain that. So every time there's a new release from NLNet, I just want to jam that in. So I mentioned the resolver strategies. This is where this really gets interesting. So you can run unwind without a config file, which already gives you 4 strategies. It can run as a recursor, basically what unmount would do. It can talk to learned forwarders. It will try to talk opportunistic DOT to learned forwarders. And it can run as a... it can sidestep libunbound and just use the libc stub. We'll later see why that is important. You can also give it a config file where you configure DOT forwarders with an authentication name. For the opportunistic DOT, it cannot validate the cert, it does not know the name, but in the config file you can put in a name and it will then validate the cert. And in the config file, you can also tweak the preferences of the strategies, and this is just the default that it runs with. All the strategies run off of individual libunknown contacts. So one of them can do its own recursion, the other one can talk to a forwarder, but these are different objects. And we found a way to have a shared cache here. We need to be a bit careful there, since you can only share a cache if the context has the same quality. It basically means it needs to be able to validate. If you try to share a cache between a strategy that does not validate, that cannot validate because signatures are stripped, if you jam that into the same cache, real interesting things happen. And this is all single threaded. We plug it in together with a lib event. So we need to figure out, are these strategies any good? And what we do for that is we ask for the start of authority record for the root zone, because we know that that exists. And we know that it's signed. And from there we can deduce if a specific strategy is any good. So we can find out, is this strategy validating? Or does it strip R6 or DNS keys, which happens on some middle boxes or happens on some open public resolvers? Then we assign this thing is resolving. Or maybe we just can't talk DNS to the outside world because 53 or 853 are blocked. Then this strategy is clearly dead and we will not hand any queries to it. Another thing that we're doing is we observe how good a strategy is, how fast does it answer. So we keep track of the round trip time and put that into a decaying histogram and calculate median of the round trip time over that. And so running the CLI tool on my laptop, I think it was online for about a week or so, and it shows me this. So this is where we calculate the quality from. And I suppose one interesting thing is the first column where the round trip time is below 10 milliseconds and all the queries ended up there, which basically means these are all cache hits. So eventually everything gets answered after the cache, except for all the other stuff, I guess. So we have all these strategies. We checked out if they're any good, and how do we do the resolving now? Well, we know to sort the strategies to find the best one, and validating is always strictly better than resolving. And then we use the median RTT for a tiebreaker. And we also have the preference to consider. The way we do that is we skew the most preferred strategy by 200 milliseconds. So if I say, I really want to do recursive resolving as the preferred strategy, what I mean is, yeah, I'm willing to wait 200 milliseconds more. But if I find myself behind a satellite link, what that usually means if I try to do my own recursive resolving and an answer comes in 2 seconds after I ask, I'm not willing to wait that long. So yeah, you can wait 200 milliseconds more, but yeah, then just give up there. So what we're doing is we pick up the best strategy, give it to libunknown to do the resolving, and start a timer, which waits the measured round trip time milliseconds. And if we do not get an answer, we try the next best strategy. And if we then wait the round trip time milliseconds, and so on and so on. Well, if we do not cancel the already running queries, because we put on all the work already, they're talking to the internet, things are happening, we might as well, while we do all the work already, maybe get a hot cache here. And we also want to know, how terrible is this actually? This will skew the round trip time in the histogram, so on the next time we will not actually use this strategy because we already know that it's bad. And this is how this kind of all started. So captive portals and DNS breakage. The captive portals break DNS, so it's kind of the same category. We used to have what your phone is doing and what the Jesus laptop here is doing and what browsers are doing is that they have an HTTP check. They just go off to the internet and do an HTTP query to a well-known URL where they get a well-known answer. And if they don't get that answer, they assume they're behind a captive portal, where you then need to click, yeah, accept the terms and conditions, and all this, yada, yada, yada. So Chrome has a URL for this, or Android has a URL for this, Mozilla has one, Apple has one. We have a CDN, we could run our own. But we could never agree on which evil corp we should trust here. And why are we trustworthy? So one night we were talking, so we monitor DNS. We know a thing about DNS. Can we do this inline? Just toss the HTTP. And turns out we can. We just need to have a look on how broken are things actually. So you find yourself behind a captive portal, you need to agree to the terms and conditions, and what the thing does, it completely blocks you off from the internet. You can only talk to the DHCP forwarders. Well, fine, talk to those, and you're done. This is simple. Then you find yourself on the Dutch Railway. And they are special. So they have an open Wi-Fi, you connect to the thing, and whenever you send a query with that has an EDNS0 option, they just answer NX domain to everything. This also turns out it's kind of okayish because, well, we do the check, does this strategy actually work? And we ask for the root zone, and this thing says, yeah, the root zone, that does not exist. Which is a cute story, but kind of, I don't trust that one. So everything will have the quality of dead, will not be used. And this is where why we have the stop in there as well. Because the libc stop does not do the DNS. So you can actually get through that thing. So you can click the terms and conditions and everything is fine. Everything is shiny. And so I actually have then a DOT configured, which then upgrades all of this to DOT. Because even if you are behind the captive portal, if you went through there, it will still answer NX domain. It will intercept your DNS. Now, then maybe you're living in the Netherlands and you want to fly somewhere. Oh no, hang on, that's the next one. Sorry. You find yourself in situations where DNS is actually open. And these are getting a bit more difficult because all your strategies suddenly say, yeah, this is totally working, the root don't exist, I can resolve this. Now you can, of course, run IP over DNS, but that's not particularly fast. The problem here is, so you get an HTTP redirect, the captive portal, the middle box intercepts your HTTP or HTTPS and redirects you to a thing which runs on the middle box. But it's not, the redirect is not resolvable on the public internet. So the resolver says, yeah, NX domain. You talk to one of the quad axes, it says NX domain. You talk DOT to one of the public one, it says NX domain. It's not resolvable. So we came up with a heuristic where we're saying, okay, fine. For the first 5 minutes, we do not trust NX domain. We just, if you get an NX domain, we just go to the stop and figure it out that way. Which works real well. And yeah, we go directly to the stop, not to the forwarders, to just sidestep the EDNS0 issue at this point. Now I'm at an airport in Amsterdam. This is brilliant. So you get a redirect, or you go to the internet, you talk HTTP, you get a redirect to the captive portal. And this one is DNSX signed. Which works out quite nicely. And so then you click, yeah, I agree to the terms and conditions, and then it forwards you to another page where it actually opens up the internet. That one is also resolvable on the public internet, but the validation fails. There are just no RR6 on this. And yeah, another heuristic there, we do not trust validation errors for the first 5 minutes. So, but so people, so I traveled with this. A lot of developers use this for their traveling, and it gets them past things. There's still some stuff that we need to work on. So when our laptops have maybe 4G cards, and they also hand us forwarders, but we need to figure out, and we just jam them in with all the other forwarders, but this is not correct. You should only use them when you're actually on 4G and not Wi-Fi. In practice, this actually works out because they are not reachable when you're on Wi-Fi, but it's still wrong. A much bigger problem is, what are we actually doing about DNSSEC? So you can say, well, be strict about this. DNSSEC is a thing. You need to always validate, and if you can't validate, then just toss the answers. Well, that's kind of not helping when you're in situations where it's really not working. Of course, you can just slam your laptop shut and go to the beach. But if you really want internet, maybe you should accept this. So there are various ideas what we can do about this. One is, do not allow a downgrade. Like you're in a network and you figure out the DNSSEC validation works, then strictly require DNSSEC validation works. If someone suddenly starts to intercept you or actively attacks you and strips all the RR6, just don't accept that. Unwind currently would do that. It would discover, oh, in this location, DNSSEC is not working, so I don't bother trying. But it cannot detect that you're actively being attacked. So we need to improve on that. Another thing is, since we're doing all the crypto on the laptop, we can actually trust the AD flag. So bubble this up to the software who actually wants to do the resolving. That one needs to decide. So I'm doing SSH my jump host, and DNSSEC validation fails. Then SSH should prompt me, yeah, do you want to trust this? But it's not doing that. And I'm not aware of any software that actually currently does this. So it's also not very helpful. Another thing, it turns out when you're behind weird captive portal, weird middle boxes, and satellite links are one of those, that they really like to intercept and munch your UDP package. They actually fake answers for you. They don't do DNSSEC, so they also strip records, and everything gets weird at that point. However, they do not understand TCP. So if you really want to talk to the internet, just use TCP. But libunwind will not do the right thing here because it also cannot know this. So it's happy to use UDP, but we know better that TCP would actually work. So the idea is that we can detect this and then have a dedicated strategy that just does TCP. Some of the captive portals you go through there, and they only give you internet for 30 minutes. And so this basically means after 30 minutes you need to reconfirm. But we already know that we are past the captive portal, so all the heuristics would not trigger. So we need to improve on that. And one idea there is that we probably can work out what the redirect domains were and track them, put them in a special pool to handle them in a more special way. A thing that was pointed out in the systemd resolve talk last year was that since the captive portals are lying to you, you should really not put their answers in the cache. And I think they talked about their solution to this problem is to dump the cache afterwards when you know that you get past the captive portal. But I really want to keep the cache. So I put my laptop to sleep all the time, and I open it, so I want a hot cache. So we need to find a better way there. And I hear reports of people using this behind DNS 6.4 and NAT 6.4 boxes, and it kind of maybe works, but there seem to be weird problems, so I need to investigate that. Anyway, that was that. Do you have questions? Many questions.
Thank you. Thank you.
In the case of the horrible airport captive portal, you said the solution was to ignore DNSSEC validation failures of 5 minutes?
Yes.
Doesn't that equate to a downgrade attack effectively?
Yes.
Okay, then. Just wanted to be sure I understand.
Yeah. No, yes.
Because all you're doing is managing downgrade attacks in the same way.
Yes, so the idea is, so we know that the network changed, that the kernel tells us this. You connected to a new Wi-Fi. We treat that special. It's a trade-off.
Many thanks for your presentation. I would like to ask you, OpenBSD community usually use Comic Sans font for presentation. Why you use another one?
First, I would like to thank the speaker for not using Comic Sans.
I will improve on that for the next time.
Oh, please. Philip?
Hi, Florian.
Hello.
Well, you mentioned SSH, which
Yes.
I find interesting because it's an application written by the same project as this work you're presenting. And I don't know if you're aware, but SSH does have code paths for DNSSEC validation. I mean, it ships with the ability to link with LDNS. That's not really worthwhile. Yeah, there are patches that also link with getDNS. That really works. But then the SSH maintainers seem to think that this is a complete non-problem and nobody would ever want to run it like this. So I hope that maybe your work will inspire the OpenSSH maintainers to merge DNSSEC validation, and then the problem should be solved for SSH at least.
I suppose so. I think the things you're talking about, these are in portable. So I don't think that the OpenBSD one can use LDNS. We don't have that in base, so this has to be in portable.
Well, maybe you should merge from portable then.
Maybe, yes.
Did you also, so I saw a list of other projects,
Yeah.
but the project DNSSEC trigger was not on there. Because it's quite similar, I think.
I can't find it on a short notice. Yeah. Is this still maintained? Is that still a thing?
Yes.
I came across it, and yeah, I don't remember the specific. It looked a bit abandoned, but no. Okay.
It's not.
Okay. Sorry about that then.
Oh, several more questions. Hold on my way.
Okay, thanks. I'm curious about how much of a pain in the ass this would be to port to something other than OpenBSD. So clearly there's the pledge thing, but what else, what other OpenBSD specific things are in there that would be horrible to port?
So the pledge thing, it's probably by now understood how to do that in portable. Other software also does that. I think the kernel integration might be problematic, where I don't even know if this is specific to OpenBSD or specific to BSDs on how to learn that an interface came up and down, these kind of things. I suppose other operating systems.
It's not NetLink, right?
No, this is a route socket.
Okay, yeah.
So yeah, I suppose there are ways to do this, and the most simple way would actually be to just use the control, the CLI, just execute a script. So if you have a way to tell, oh, my network changed, pipe this through the CLI, I think that would be the easiest way. And other than that, I don't think there are that many things that would not be portable.
Right, so like IP monitor on any Linux, which just gives you stuff through a pipe.
Yeah.
Okay.
I suppose.
Okay.
Yeah.
Any other questions? Here's one.
I was just wondering, when you said that you one of the strategies is to run your own recursor, like, for example, when you're at your office, how do you resolve printers if it suddenly doesn't trust the DHCP provided forwarder?
Yes. Where's Otto? Otto, do you mind answering that?
There's a similar question about the Firefox DOH stuff, of course, but that's not this talk.
You can configure any name or domain and redirect all queries for that domain and anything under it to a specific resolver, which is typically, let's say, a solution to your split horizon thing in your office or in your home office. DNSSEC can be used in that case, but also can be switched off for those names, which in general, I think, even in our office, do not work that well.
Thank you. All right, I have time for one very quick question.
So I can show this slide. This is actually the better one, I thought.
Does that good have a title? All right, thank you for your talk.
Thanks.